50 billion devices connected by 2030. 180 zettabytes created by 2025. More than 7,700 satellites currently in Earth's orbit. What can we do? We build open source software to solve infrastructure problems. We create diverse, inclusive, sustainable communities. We meet locally, regionally, globally. We collaborate without boundaries. We're OpenInfra. Thousands of deployments across every industry. More than 10,000 individual contributors with 650,000 changes across 65 countries. 700 supporting organizations. 110,000 individuals across 187 countries. With one mission: build the next decade of open infrastructure.
Please welcome to the stage Allison Price and Wes Wilson from the OpenInfra Foundation.
Welcome to Vancouver.
We're back. How has everyone's first day been? Yeah. Woo. Awesome. Well, someone you should thank for that is our sponsors of this event. So we have a great lineup of sponsors who are exhibiting upstairs in the OpenInfra Marketplace on level 2. So if you haven't had a chance to go meet them, please do. They are all innovating and collaborating around an open infrastructure, just like all of you. A special shout out to our headline sponsor, Wind River, who we'll hear about in a little bit. Tomorrow, if you like the snacks and drinks here, we'll have more. So there will be a marketplace mixer for you to meet all of these organizations and talk about ways you can collaborate. Please join us upstairs tomorrow at 4:30 to 6:30, or 4:30 to 6, sorry, just to get to know each other and also mingle with your fellow attendees.
Yeah, we've got quite a bit of good stuff here. You've probably already experienced some of this, but we have more than 100 breakout sessions here at the summit. We also have a forum. We also have a PTG. You can find all of that on the summit schedule at openinfra.dev/summit schedule.
Summit-schedule.
Schedule
Okay.
for Mark.
So what's exciting is over half of you are actually at your first OpenInfra Summit. You may have been to an OpenInfra Day, which has been organized by volunteers that we'll be recognizing shortly. But PTG is not necessarily something as familiar as breakout sessions or just collaborative discussions. So maybe, Wes, you can talk about what the PTG is.
Yeah, so for those of you that are new, the PTG is basically a place where all the project teams get together and they plan out the next release of the software. So if you have done any contributing, if you want to contribute, definitely go to the PTG. That's going to be in this room tomorrow and Thursday. If you have not signed up your team yet, please do that using the PTG bot at the URL here. Or if you just want to find out what the schedule is, that's the place to go.
Yeah, and what's really exciting, so this has been a place where the Kata containers, the Starling X, and all of the different OpenStack project teams have come to collaborate over the past several years. But for this PTG, what's really exciting is that several other open source communities reached out to us wanting to participate, to collaborate with our other open source infrastructure projects. And to me, that's just really exciting because that's the entire point of this event and what we do. So Rocky Linux, Alma Linux, CentOS, Ceph, all of those communities are here this week. So if you have questions about integrating the different components together or you want to contribute to those projects, the PTG is a great place to go, as well as the different breakout sessions that Wes mentioned.
Yeah, so the community is hiring. There are lots of folks hiring. We have a jobs board up on the OpenInfra Marketplace. If you have jobs to post, you can post them there. If you're looking for jobs, that's where you can go to find some as well. And for the first time here, we are also doing a courtesy resume review. So if you are on the job market, you can send your resume to community@openinfra.dev, and then someone at the foundation will review it and provide feedback and send it back to you.
There are other places where you can collaborate with some of our members as well as just your fellow attendees that are very specific and niche. So one is the contributor lounge upstairs between the two forum rooms. It is where you can go have some casual meetings, charge, which we all need, and just kind of have a way to mingle. And so thank you to Canonical for sponsoring that lounge. And then on Thursday, from 7:30 to 9, we are going to have a speed mentoring breakfast sponsored by Red Hat. There will be pancakes with real Canadian maple syrup, so I hope most of you are there. There's a technical, a career, and a community track. And so if you either want to get involved in either of those, any of those areas, or you'd like to mentor someone, that kind of opportunity is always welcome. So please join us on Thursday morning for breakfast. And then tomorrow, we will have a diversity and inclusion lunch sponsored by Bloomberg, where you can come meet your fellow attendees and talk about some of the hot topics around diversity and inclusion in the OpenInfra community. In addition to that, I want to do a special call out to our OpenInfra Foundation Diversity and Inclusion Working Group, and a special thanks to Amy Marish, who dedicates a lot of her time to this initiative. Woo! Amy. I know they just had a forum session to get feedback on this survey, but they also meet every other Tuesday, I think. So, what? Second Tuesday of the month. We're getting it live here.
Audience participation.
Yeah, exactly. But one of the really exciting things that has happened over the past several months is an update to the diversity and inclusion survey to be more inclusive. So if you have feedback, we welcome that, but we really want to encourage everyone to take this survey because diversity and inclusion is something that the OpenInfra Foundation really wants to support and evolve so we can have more people feel welcome and lower the barriers to entry.
Well, perfect. So now that we've gone through all the housekeeping stuff, we are going to kick off the keynote with our general manager, Thierry Carrez.
All right.
Hello, everyone, and welcome to our 22nd summit. We've brought the summit all over the world, so from Austin to Paris to Tokyo to Sydney to San Diego, Vancouver, Shanghai. And it's always been a pleasure for me to meet you all at all of those events around the world, to attend so many interesting talks, to have so many interesting discussions, and just collaborate to make the software better. Like Alison said, about half of the audience, for about half of the audience, it's your first OpenInfra Summit. And so you may not know that this is our third time in Vancouver. We had a summit in Vancouver in 2015, and back then it was still called the OpenStack Summit. And since then, we have expanded our mission, and we have renamed the summit to OpenInfra Summit. We have renamed the foundation to OpenInfra Foundation. OpenInfra is short for Open Infrastructure. So what do we mean by open infrastructure? Well, let's break it down. First, let's look at open. Open means open source, first and foremost. But beyond the licensing, it also means openly developed, openly designed, and openly governed. And those four open principles are essential to creating healthy, sustainable communities, which is key to producing long-lasting infrastructure software. Next is the word infrastructure. With our experience in OpenStack, we realized two things. That it was serving a new population of operators of infrastructure that are interested in using open source solutions for providing infrastructure. It's really a new role that we are seeing emerging within organizations, within companies. And the second thing we realized is that this new population was interested in more than just OpenStack. In practice, open infrastructure sits between hardware and application servers for everyone to build and innovate on top of. This is a space that benefits a lot from commoditization and standardization. It's a space where we can openly collaborate on common solutions because there is a way to monetize and differentiate on top. And in reality, if you look at history, it's a relatively new idea. Back when we started this in 2010, open source was not the dominant force it is today. On the infrastructure side, there was basically one big proprietary player in the private infrastructure space. There was one big provider relying on a proprietary stack of services in the public space. And with that, you can imagine all the side effects like monopolies, high prices, vendor lock-in, limited customization, etc. And we started our journey back in 2010 to create a better option. We wanted to build open source solutions for providing infrastructure and make those key technologies available to everyone. Our idea was to build something for anyone, to do anything, to use anywhere. We wanted to make sure that anyone could have access to those technologies. We wanted to make sure that they could use them to do anything without asking for permission. And that those solutions would be available anywhere to help distribute the future more evenly. And we started doing just that. We created OpenStack, which was the first open source cloud software with a universal focus, being usable by anyone to do anything. But what OpenStack really created is a space to discuss open infrastructure. And this gave other projects like Ceph, like Open vSwitch, like KVM, a space to be discussed, to be integrated, to be exposed to the world. And they were soon joined by other projects. Kubernetes was created really with the same principles in mind, and we got Kata containers and Zool and Starling X and all of those other projects. They're all targeted to the same audience, infrastructure providers interested in using, developing, deploying open source solutions for providing infrastructure. It could be with the goal of building a completely open source stack, but it's also with the goal of just using one open source piece in an otherwise proprietary stack. And this week at the OpenInfra Summit, like Alison said, we'll have all those communities getting together. OpenInfra projects, but also Kubernetes, Alma Linux, Rocky Linux, CentOS, Ceph. And Ceph will actually have their Ceph days here on Thursday. So please be sure to check out Room 18 and talk to the Ceph community more directly. All those communities share our goal to produce infrastructure software for anyone to do anything, to use anywhere. So where are we today? I would say we have succeeded. Today, anyone is everyone. Anything is everything, and anywhere is everywhere. And I'll spend the rest of this keynote to actually explain what I mean by that. So first, anyone is everyone. This really talks to how we set out to reach potentially anyone, and we succeeded, and we ended up reaching out to a lot of people and being used on a lot of computers. We started with 150 community members back at the inaugural Austin OpenStack Design Summit. And today we have more than 110,000 community members all around the world. We started with a couple of organizations, Rackspace and NASA, and now we have more than 700 organizations involved in OpenInfra. Looking at OpenStack, more specifically, OpenStack usage, our latest user survey reports more than 40 million CPU cores of computing power being driven directly by OpenStack. That's not only a huge number, it's actually growing faster than ever. If we look at the contributor side, we went from dozens of contributors to thousands of contributors. And Kendall will spend more time explaining these charts, which were generated from the Bitergia dashboard that we'll be announcing later. Anything is everything. This talks to how we set out to build tools to allow permissionless innovation that could be used for any use case. And we succeeded, and those tools ended up being used for everything. We started with 2 use cases, Rackspace with the public cloud and NASA with the research cloud. And today, OpenStack and OpenInfra software is used in gaming, in finance, in insurance, in telcos, all of those areas and verticals of use cases that we were not designed specifically for doing it originally. Looking at Kata containers, more specifically, Kata Containers is securing container workloads at N group, powering the largest payment processor in the world, Alipay, processing more than 100 million payments per day and being used by over 1 billion users. Kata Containers also available on Microsoft Azure Kubernetes service, powering confidential computing features there, which is really huge because it's the first hyperscale cloud to come out and say publicly that they are using Kata Containers to secure their container workloads. And we'll talk more about that today during the keynotes. OpenInfra has become so ubiquitous, you can actually spend your whole day powered by OpenInfra software. You can start the day playing some game powered by Blizzard and OpenStack. You can take out in your Volvo, and if you don't crash your Volvo, it's probably because Zool has helped testing the software that runs it. You can pay with Alipay something, your coffee at the coffee shop, and that's powered by Kata Containers. And you can check out your friends using Verizon, powered by Starlink X. So today, OpenInfra covers really everything, which really brings the question, where does OpenInfra go tomorrow? There is clearly more space to explore between hardware and application servers. For example, software to integrate new hardware features. We could have more open source components used in proprietary public cloud stacks. We can go beyond addressing the everything of today and addressing the everything of tomorrow. We're really seeing new use cases that drive new requirements on infrastructure, and we need to meet those. In security and privacy, in artificial intelligence, in environmental sustainability, in more hardware integration. And throughout the rest of those keynotes, we'll go into a lot more details around distributed computing, confidential computing, and AI. Finally, anywhere is everywhere. This really talks to how we wanted to collaborate without boundaries and give access to those technologies anywhere, and not just in a very few countries around the world that can actually afford it. And we succeeded, and our community is now truly global. We are in over 182 countries, and that kind of reach is not possible without the passion and the coordination from individuals who rally their local communities together. And to talk more about that, I welcome on stage Helena Spies, who will talk more about it. Helena.
Thank you, Thierry. It's great to be here this week at the OpenInfra Summit. As Thierry mentioned earlier, the infrastructure world used to be entirely proprietary, but the OpenInfra Foundation revolutionized that. And where the OpenInfra community especially shines is exactly in that, the community. So I would like you to join me in welcoming on the stage our community organizers. Folks up here, but this is only a small portion of them, actually. There's over 50 meetup groups around the globe, and these people are the heart and soul of the OpenInfra community. They provide means for collaboration regionally through meetups, OpenInfra Days, and more. Within these 50 communities around the world, there's an organizer for each of those, and often a coalition of co-organizers behind them. So that's so many organizers. Heart and soul of the community. In addition to that, we often have people here in the audience, too, who provide means for venue space, sponsorships, speaking opportunities, and more, and provide to these meetups at OpenInfra Days. So I'm going to hand it over to the heart and soul of the community to introduce themselves.
Hello, everyone. So my name is Li Haoyang. Organizers from Shanghai.
Hello, I'm Adrian Cunin. I'm one of the organizers for the user groups in France for the cities of Paris and Rennes.
Hi, I'm Nils Magnus. I'm based in Berlin, Germany, in Europe.
Jonathan Race, based out of Augusta, Georgia, United States.
Robert Holling, located in Lingen, Germany.
Alan Cantrell, based out of Augusta, Georgia, United States.
Hi, I'm Rico Ling, based in New Taipei City, Taiwan.
Hi, my name is Akihiro Hasegawa from Tokyo, Japan.
Hi, I'm Sash Ghosh, and I'm representing Los Angeles, California, United States.
Hello, mi nombre es Álvaro Soto. I'm from Mexico City.
Hello, I'm Sung-soo from OpenStack Korea User Group. Thank you.
Hi, my name is Jeff Ji-Wai Kim. I'm community organizer in Korea. Thank you.
Charles Pike, Kentucky.
Christian Yashevsky, Raleigh, North Carolina.
Apisak Shuvia, Bangkok, Thailand.
Andy Botting, I'm based in Melbourne, Australia.
I'm Kenneth Tan, I'm in Frankfurt, Germany.
One more big round of applause for these folks. Thank you for all your hard work. Thank you. So if you want to hear more about the community and meet these folks in person, up close, you can meet them tomorrow at 4:30 or 4 p.m. Alvaro Soto will be giving a talk on the cultural challenges of open source in Latin America. Directly following that, we will have the Marketplace Mixer, where not only can you mingle with our sponsors, but you can also meet our organizers and talk about how you can collaborate regionally with them. Thank you.
Thanks, Helena. Thanks to all the OpenInfra Day organizers. They're really the local relays for our community in all of those local areas. So it's really a very important part of our community. Their work really shows through all of those OpenInfra Day events, but also their contributions, usage, and even foundation membership. So open source, and more specifically OpenInfra, is truly global. But we are not guaranteed it will stay that way. We are not guaranteed another decade of collaboration without boundaries. Today, everywhere is at risk. We could see from the difficulties that a lot of you had to get visas traveling here, that boundaries are a strong reality. And there are more and more geopolitical tensions, more and more ill-informed regulations that have the potential to destroy open source and open collaboration the way we know it. For example, the Cyber Resilience Act in Europe, which does not take into account the specificity of open source in the regulation, which may have chilling effects on future development. If we want to have another decade of open source, another decade of open innovation without boundaries, we need to take action. This is something we've been thinking about a lot, for a long time, and today we're ready to take action. Today we are announcing OpenInfra Europe and OpenInfra Asia, two regional hubs of the OpenInfra Foundation. We really reached critical mass of activity in Europe and Asia, and it's very important for us to be able to aggregate regional voices on how to best respond to regional challenges, but also just generally strengthen the regional ecosystems and help coordinate local communities. In Europe, we need to place OpenInfra front and center in the digital sovereignty debate, and also address more directly EU-proposed legislation. And our members based in Europe, Ericsson and all the others, have answered to our call. In Asia, we have exceptionally strong local communities and markets that we need to enable at the regional level. And our members in Asia, including Ant Group and Huawei, have rallied around this objective. If you want to become a participant in either of those organizations, please go to those websites. Members of the OpenInfra Foundation can get to participate in those regional hubs at the same level as their membership at no additional cost. We're excited to see how those new regional hubs help coordinate the community regionally and tackle those crucial challenges ahead of us, and see how they help us ensure that OpenInfra continues to be used by everyone, for everything, and everywhere. Thank you.
Thank you, Thierry. That was great. Exciting announcement. We're really excited about these regional hubs. So one of the things that he mentioned quickly with the Bitergia graphs is the growth and contributor contributions. We have some sessions here that if you are a contributor, which I know a lot of you in this room are, you should definitely check out. The first one is tomorrow at 11:40. It's a forum session that's discussing a new community blueprint initiative. And the second one is on Thursday, also at 11:40. Which is a panel about balancing, if you're an individual contributor, balancing organizational needs with upstream contributions, both very interesting topics that you should check out. So up next, we are going to move on to something called Loki, which don't want to spoil, but Linux, OpenStack, Kubernetes infrastructure. Ildiko Vanska.
Hello, everyone. Good afternoon. Are you all having a great time with OpenInfra? Woo! All right, get ready, buckle up, because my fellow speakers and I will take you to a little technology journey. And as Wes mentioned, that will be all about Loki, and I will just repeat, Linux, OpenStack, Kubernetes infrastructure. So, who in the audience have heard of Loki before? All right, we got a few hands. So, let's start our trip where it all began. So this diagram is probably resembling memories for some of you, and for others, it looks a little bit more like a history lesson. I will not turn it into one. But for example, I was only 7 years old when the initial release of the Linux kernel came out in 1991. And it took a lot of time until I learned and realized how historical moment that was for open source and open source infrastructure. So 19 years later, we had a lot of servers in big warehouses that we called data centers that were running Linux. And what was revolutionary about that is we started to treat these big data centers like if they were one big machine. So if you will, the data center became the new mainframe. And that mainframe needed an operating system. And in the open source space, that operating system is now OpenStack. And what really enabled OpenStack was the success of Linux. Linux as an operating system and Linux as an open source project, or despite of being an open source project, I will leave it up to you to choose which one you go with. And if you look at the timeline a little bit closer, you will see how open source and the success of open source and open source infrastructure accelerated, because from there, from 2020 when OpenStack was created, it only took 4 more years to the announcement of Kubernetes. And by today, these 3 infrastructure components became key, and they are frequently used together. And now we are just conveniently calling them the Loki stack. And for many of us nerds, this is already super exciting. But in reality, what is technology if nobody is using it? So when it comes to Loki, Loki currently is powering critical functions around the globe. So a couple of examples, because there's no Keynote without CERN. CERN is using Loki to process massive amounts of data that is coming from their experiments to discover, prove, or break the laws of physics. China Telecom is providing connectivity by using Loki through tens of millions of users just in China and even more customers globally. Bloomberg is using Loki to give all of you information because, let's be honest, we are all really hungry for information these days. So Bloomberg is supplying you financial data, news, and really all the information you could possibly want. So these organizations are very different, but yet they still have a lot in common. Super User Awards. CERN was the first winner, and Bloomberg and China Telecom are both nominees this year, and I will not tell you who the winner is. You will have to wait a little bit longer for that. What else do these organizations share? They all run infrastructure on a massive scale. CERN's OpenStack-powered cloud is over 300,000 cores, and they are using OpenStack Magnum to run Kubernetes clusters. China Telecom, they are running Loki in over 700 data centers. Bloomberg, their OpenStack cloud is over 400,000 cores, and they are running hundreds of Kubernetes clusters, both bare metal and virtual. So you might think that this is where this all ends, but that is not exactly true. So let's go back to technology evolution a little bit. We started with single computers, we put them in data centers, we created software to harness the power of those massive, large amounts of resources, and we did all that just to break out of the walls of those data centers, take the cloud computing concept and computational power, and, well, deployed it everywhere. But this is what we are trying to do. But when we are arriving to this modern infrastructure, we have to realize how complex that is, and we also, unfortunately, have to realize that complexity is not going anywhere. However, there is good news in this because there is a solution, which is automation. And if you think that I will send you back to the drawing table, that's not true, because the project that delivers you this automation already exists. And it's called Starling X. Starling X took the Loki components, and he flew with them. And Starling X, as an open source cloud platform, doesn't just provide you with the components of the Loki stack, but it also adds those missing pieces that allows you to take Loki outside of the walls of data centers and deploy and manage them as geographically distributed systems on a smaller scale or a large scale. It is all your choice. We announced the project 5 years and exactly 1 month ago here in Vancouver. And today, as the next part of our journey, we will dive into the why, what, and how of Starling X. And for that, I would like to invite Jeff Gowen to the stage.
Hey, everybody. So we are in Vancouver, so I thought I would start my talk in the most Canadian way I could think of, which is, I'm sorry. VMs have been around for decades, right? But it was in 2010, and I'm sorry if we're going to inundate you with timelines. You've seen them a couple times already. But in 2010, that's when OpenStack came along with the mission statement, and I'm going to read it out loud, to produce the ubiquitous open source cloud computing platform that will meet the needs of public and private clouds regardless of size by being simple to implement and massively scalable. So based on what we heard from Thierry, I'd say mission accomplished, right? So OpenStack provides the infrastructure needed to deploy VMs at scale. And OpenStack has helped us to realize what would have been considered science fiction 10 to 15 years ago by providing the infrastructure to support the internet and modern networks as we know them. But human nature is to evolve, and the goal line has moved. So now the expectation is for things like self-driving cars, always-on connectivity everywhere, smart cities, and the list goes on. Thankfully, in 2014, along came Kubernetes. So Kubernetes is designed for distributed systems. And just like OpenStack provides the infrastructure for virtual machines at scale, Starling X provides the infrastructure for Kubernetes at scale in a distributed system. So why am I telling you this? Because at some point, you're likely going to be asked to deploy, manage, operate applications in a distributed network. And when that happens, there's a few things that you might want to have available. So you might want to have a geographically distributed solution spanning thousands of systems. You may want to have support for containers and virtual machines out of the box. You may want to have high performance in terms of latency and uptime. Easy automated deployment, that sounds like a no-brainer, right? And operational ease of use features like centralized management and automated operations. What's happening is applications are being pushed closer to the user, and they need infrastructure that can support them where the compute and where the data are. See, suddenly the modern data center starts to look a little different, right? A new data center might actually have wheels. It might have wings, as in the case of a car or a jet fighter. As one of my colleagues recently said to me, there is no center in data center. Now, that sounds like a line out of a Matrix movie, but what if it's true? If it is, what do you do? Well, the good news is you don't have to figure out distributed systems by yourself. Starling X has already solved many of the challenges of a distributed system and is adaptable to so many more. If only it were running the slides. My name's Jeff Gowan, and I'm the marketing director at Wind River, and I'm also an active contributor to the Starling X marketing team. And I'm joined by several community members, you can identify them with these shirts, who would love to get into the technical weeds of Starling X with you over the next 2 days. Wind River is a contributor, and we are a believer in Starling X. So Ildiko just talked about Loki a little bit. So what if you could get Loki with all the pieces assembled and field proven? Well, that's what Starling X is. It is Loki distributed cloud infrastructure, and it's running in some of the most demanding environments today and is adaptable to many, many, many more. And also, as she mentioned, we are celebrating Starling X's 5-year anniversary. So 5 years ago, here in Vancouver, we launched the project, and I was actually with the project from inception, and it is definitely not the same software as it was 5 years ago. Today, Starling X provides the edge infrastructure for Verizon's 5G network in North America. And I'm going to talk about that more in a little bit because it's a great example of how the project is getting pushed. Because as use cases evolve, so must Starling X. Because if we're only thinking from a data center perspective, we will literally be boxed in, and we will be unable to meet the emerging needs of the edge. Next generation use cases need next generation infrastructure. So what I'd like to do is just give you a little bit of food for thought in the immediate, near, and longer term future about deploying applications in a distributed environment. So maybe you're responsible for managing and operating enterprise data or multiple enterprise sites, each with their own data center. So rather than thinking of them as separate standalone entities, what if you could manage them all centrally? Well, one idea is to think of them as clouds and subclouds rather than separate standalone entities. Each of those sites, of course, has its own needs in terms of software installs, updates, version control, availability, the list goes on. But if you think of those sites as a collective, it gives you more options on how to implement those needs. So, for example, how do you keep each site up to date and synchronized on the same version while not disrupting service? What about security updates? How do you orchestrate the updates of all the applications needed? These are the types of things that Starling X does. So if you think Starling X might be able to help you with your enterprise sites, come talk to us. So the next example is, once you've implemented your distributed system, then how do you scale? So for the last 2.5 years, Verizon has relied on Wind River Studio, which has commercially supported Starling X for their 5G network. And with 10,000 sites and growing, they're all about scale. And I'll give you a little secret. Distributed networks are really complex. So this is why, in addition to some of the core features of Starling X that include single pane of glass and zero-touch automated management, this year, the key area of focus is around operations at scale. And there's a number of features in version 8, which was just released. I'm not going to go through the whole list because unfortunately I don't have time. But if you're interested in some of the latest releases of Starling X and operations at scale of distributed systems, come talk to us. So the third example, as we think to modern use cases and use cases of the future, we're going to start to really see how today's technology just isn't going to cut it. The simple fact is, distributed is different from the data center, and a data center alone isn't going to be enough to support use cases like a mobile distributed cloud. So what might that be? That might be a fleet of automobiles that are operating as an autonomous taxi network. It could be a fleet of drones that are being used to distribute medicine into remote environments or to packages to your home. Or it could be traffic control in a smart city that requires V2X connectivity, smart city integration, 5G connectivity, and a myriad of sensors and applications that all need to be managed real time at the edge. Whatever the use case is, having a distributed cloud technology will enable some certain things that you're going to want for those use cases. Things like predictive maintenance, things like remote monitoring of fleets and your assets, mobile application deployment, and data analytics to improve your operations. So I just walked through some examples of existing and potential use cases, and what they all have in common is a distributed cloud hierarchy that can be thought of as clouds and subclouds separated by geography. Now, honestly, we're just getting started, but Starling X has a serious head start. Telecom operators, they've been building out their networks for connectivity for years, and other industries like automotive are starting to catch up on their own digitization journey. And what's happening is this convergence of initiatives is opening the door for Starling X to be able to play a role in outside of telco. If you think of it this way, telco has been hardening Starling X for the rest of the world. So on the topic of telco, one area that is super hot in telco and very important is energy efficiency. And one way that Starling X is addressing that is through extreme efficiency. So one example of that is the fact that we can now run on a single core of the Intel 4th generation Xeon processors. Some of you might know that as Sapphire Rapids. Why this is a big deal is because by being able to run on a single core, that means you can run other applications with the existing cores, and that could potentially reduce the number of servers that you need per site, which will then in turn, of course, reduce the amount of power that's needed for those sites. Now that may not be a big deal for a single site, but when you multiply that across thousands of sites, it suddenly becomes a big deal because you just don't have the same economies of scale with the single data sites as you do with a huge data center. So we have a demonstration of Sapphire Rapids and Starling X in the Starling X booth. Come take a look at that. Another example is ARM. So ARM recently joined the Starling X community, and there is a POC of Starling X running on ARM in the Starling X booth. There's also a session tomorrow. It's called Power Efficiency in vRAN and Open RAN, where we'll get into the details of that POC. So I'm going to wrap it up by just highlighting a few things. Number one, the world is evolving quickly. Number two, legacy technology is awesome at what it does, but it can only do so much. If you think of the networks of the future, there's only a portion of it that's going to be within the four walls of a data center, and there's going to be an increasing portion of it that could be pretty much anywhere you can think of. And number three, we need to think out of the data center box, because if we assume that distributed edge is the same as the data center, we'll miss. We will miss on delivering healthcare for remote areas. We will miss on smart, coordinated city planning. And I hate to say it, we will miss on drone delivery of cold beer and pizza. However, sorry, before I get to that, the reason why is because the edge won't be secure. It won't be manageable. It won't be reliable. And all the things that are going to be required for us to have the confidence to both provide and consume those services. But if we think distributed, then all of a sudden we're thinking about new commerce models, new innovation models, actual evolution, because we have the actual infrastructure to support it. Again, next generation use cases need next generation infrastructure, and this is why Starling X wants your contribution. What do you want to build? What applications do you need to support? If you think Starling X could potentially be used for you, we invite you to come talk to us. Come grab us in the booth. Pretty much anybody who's wearing a shirt that looks like this, grab them and ask them about Starling X and how it could potentially help with your use case. And if you do a search for Starling X in the agenda, you're going to see a bunch of sessions. There's the energy session that I mentioned that's happening tomorrow. And I wanted to call out one session in particular on Thursday, which is the hands-on session. So if you want to roll up your sleeves and really get into the technology, join us Thursday morning, and you'll get the opportunity to do that. So with that, I will say thank you very much.
Thank you, Jeff. This was very exciting. I always get the chills when I learn more about the capabilities of Starling X, the use cases that it supports today, and also the use cases that it will enable tomorrow and further out in the future. And Jeff already mentioned a couple of sessions, conference sessions that you can find on the schedule, but I also like to give a reminder that Starling X is not just a software piece, it is also an open source community. So please, not just go to those sessions, but also keep the project teams gathering in mind, where Starling X has a session tomorrow afternoon starting at 2:30 p.m. And go and mingle with the contributors of the project. Ask them about how it works, and ask them on how you can get involved. Go to the hands-on workshop, and we also have a forum session Thursday afternoon, I think it is at 2 p.m. So go and find the people who are working on that platform and have a conversation with them. And now, with all that, we sadly arrived to the last part of our journey. But I already told you to buckle up. So this is now when you will be holding on to your seats, because we are taking a magnifying glass and we are taking an even closer look at Loki, and more specifically the OpenStack and Kubernetes parts of it and how they are working together, not just as projects, but also as communities. And our next speakers will not only just speak, but also show you all that as part of a live demo. So please welcome on stage Kendall, Matt, and Guilherme.
Hi, I'm Matt. I'm a principal software engineer at Red Hat.
Hi, I'm Guilherme. I'm senior OpenStack engineer at VaxHost.
And I'm Kendall Nelson, a senior upstream developer advocate at the OpenInfra Foundation. So, Guilherme here is going to dive right into this demo so that we can make sure it completes in our 8-minute segment. So, basically, Matt and I are going to introduce the topic Loki, which you may have heard of by now, but Guilherme over here is going to do an upgrade of a Kubernetes cluster running on top of OpenStack, and he will also be spinning up a new cluster on top of OpenStack. So, we've heard about this Loki thing now, hopefully. So this comes from the OpenStack user surveys that we've been seeing over the last couple of years. There is a preference and a pattern for using open source for the whole infrastructure stack, specifically using Linux, OpenStack, and Kubernetes together to provide your infrastructure. These three projects together provide a fully open source stack from top to bottom.
So, quick show of hands. Who here is already running Kubernetes on OpenStack? That's quite a few. Quite a few. But I'd like to take a minute to talk to those of you who didn't raise your hands. There are lots of reasons to run Kubernetes. But one of the biggest ones is that it's cloud agnostic. It allows your users to focus on the needs of the application rather than the cloud that it's running on. This also means it's possible to reuse Kubernetes deployments across clouds. If it's currently running on public cloud, there's a good chance that you can run it on OpenStack with minimal or even no changes, and vice versa. But of course, there are also reasons against. And one I've heard frequently is complexity. The good news is, if you're running OpenStack, you've already implemented much of that complexity, and your Kubernetes cluster can just use it. And you can reuse it as many times as you like by running multiple clusters. Kubernetes clusters on OpenStack are cheap and easy to create. And to OpenStack, it's just a regular tenant workload. No admin privileges are required, No special installation is required, and your users can even do it for themselves. OpenStack was one of the first clouds to have native integrations in Kubernetes. They're very well tested and very mature. Running OpenStack on Kubernetes is a cheap and easy and safe choice. But don't take my word for it. Let's have a look at what Guilherme has been doing so we can see it for ourselves.
Sure, Matt. So basically what I did here, I'm logged in as a member user of a project. And to be honest, there's nothing new here for whom already used OpenStack and Magnum before. I just navigated here to the container infra. I just selected the cluster I wanted to upgrade, selected the cluster template with a higher version of Kubernetes, and that's it. To create a cluster, simple as well. So just open up a form, just put the name, the cluster template, a key pair, and the number of nodes. And that's where the magic happens. Actually, the key point here is how the magic happens, actually. On this deployment here in particular, we are using a new Magnum driver. It's called Magnum Cluster API. It's a driver developed by VxHost. So as you can see here, this is the actual driver working. So that's cool, isn't it, Kendall?
Very, very cool. With 2 clicks, you are able to effectively upgrade a whole cluster. And I think that we can all agree that that's a really refreshing upgrade experience. Cluster creation is cheap and easy too, like Matt said. You had a predefined cluster template, and by customizing 3 parameters, I think it was, you can stamp out as many as you want. Everyone can have their own cluster. He can have a cluster. You can have a cluster. I can have a cluster. And as you mentioned the Magnum API driver, I know that that makes use of another open source project called Cappy. Matt, can you explain a little bit about Cappy?
Sure. Cluster API, or Cappy, is a Kubernetes native API for managing Kubernetes clusters. It can install a new cluster, it can scale or reconfigure your existing cluster, and as Guilherme has just shown us, it can quickly and easily upgrade a cluster. And it supports lots of clouds, not just OpenStack. There are providers available for just about anything you're likely to be running on, whether that's public cloud or private cloud or even bare metal. And wherever you deploy it, the Kubernetes that it deploys will always be the same, managed in the same way and exposing the capabilities of whichever cloud it's running on. So on OpenStack, for example, that means you can do things like mixing and matching virtual and bare metal workers all in the same cluster. Another advantage of Cappy is that it's managed under the same umbrella as Kubernetes itself. So it always supports the latest releases. By building on Cluster API, Magnum can take advantage of first-class Kubernetes native management tools and expose them for an OpenStack native API.
So there we go. We have the upgrade complete. We have a cluster creator complete. I just did here, with this command here, just pulling out the config of the cluster I created. So it writes a file on the disk. I just export it, and there we go. That's the cluster we created. So simple and easy.
I love it when a live demo works. It's awesome that we can, yeah, right. Yeah, it's awesome that we can see these commands actually completing in real time, and that was all maybe 6-ish minutes. And even better that you are actually able to use the OpenStack CLI and dashboard that most of us are already familiar with. So, Guilherme, can you actually tell us a little bit about the environment that we're looking at, too?
Sure. That's a proof of concept box. This is running inside Atmosphere Cloud. That's the public cloud for VxHost. So it's running Atmosphere. Is another project that VxHost has developed. It's an open source project as well. It's responsible to deploy OpenStack on top of Kubernetes. So my colleague Rico Lin, he's going to be talking about Atmosphere in a little bit more details during the event. But that's it. So this environment is running Atmosphere, and it comes with Magnum Cluster API by default. So
awesome. So while we have this lovely audience here today, what sort of help can we ask them for in this space for CAPI and Magnum?
So the CAPI community is vibrant and diverse, but we'd still like to see much more participation from members of the OpenStack community. If you're an OpenStack developer, we'd really like you to come and contribute to one of the OpenStack integrations. Please come and talk to us about it in our forum session on Thursday afternoon.
Yeah, so Atmosphere and Magnum Cluster API, they are open source. Just feel free to go to VexHost GitHub repository. You can just clone the project and try it out by yourself. We would be really happy to have your contribution there.
Awesome. Lots of places to get involved, and we really need everyone's input. I want to give a huge thank you to those such as yourselves that have paved the way to get us to the point where we can use these projects together to make our Loki stack. And I hope that the audience would now agree that we've proven the Loki stack to them and they're ready to go try it out for themselves. Thank you all for giving us the time, and yeah, demo that works. So let's take a step back in time for a moment. From 2010 to 2011, we kind of saw OpenStack getting started. Hopefully we'll see a really cool graphic here in a moment. And it wasn't very big. We didn't have a lot of people. There weren't a whole lot of projects. But hey, here we go. If you take a look at this image, so there's all these blue dots. Those are actually contributors working on the projects in OpenStack. And the orange dots are the projects themselves. So that little orange dot off to the left, all by its lonesome, but kind of connected in, that's Neutron. And the one that's trying to be a nebula of its own at the bottom, but still connected, that's Swift. But today, we have a much more dense and interconnected community. And there are more projects and more contributors than we've had before. But being able to see the community represented in this way is thanks to Bitergia. The OpenStack dashboard that these images were pulled from is now available for your own perusal. So anyone can nerd out like I did and start doing visualization of growth factors in OpenStack. And where obviously containers and integration with Kubernetes weren't the only factors between 2010 and now, you can see the projects highlighted that are related to containers like Magnum, Cola, and OpenStack Helm. I really, really love this. But if you want to dig in as much as I did, the data is now available to you via the new OpenStack dashboard. And if you have questions, Bitergia will be hanging out in the metrics corner throughout the event in the marketplace. Go check it out. Thank you.
Thank you, Kendall, and also thanks to Guilherme and Matt. Did you all see how smoothly that live demo went? Was it amazing? Woohoo! And through that demo, you could see how smoothly and nicely integrated OpenStack and Kubernetes are. But that really is the result of two very large and very active communities actively collaborating and working together to make that happen. And you can learn much more about Loki this week. So even though that this is the end of our little trip today, this is the beginning for all of you, because this is when you can go and mingle with fellow attendees, contributors, and really anyone who you can find around you, like-minded people, come up with new ideas and collaborate on solutions. So make sure to attend the conference sessions, go check out the PTG and mingle with the contributors there, and go and give feedback and talk about ideas and priorities at the forum sessions. And with all that, thank you all for your attention, and remember to have a great time with OpenInfra.
So the first segment is done. Thank you to Ildiko for hosting it. I hope you noticed that one of the things that we did really intentionally with the keynotes this time is bringing up the contributors who are building the software and showing it with demos and providing some really technical overviews. So we have a lot more demos still to go. But before we get to the next one, you know, OpenStack and Kubernetes integration that we just heard about is one of the most commonly talked about topics at the OpenInfra Summit. But within the summit, and even around the entire world, the most talked about topic right now is AI. And so we're going to have a segment around AI and how different open source technologies are pushing the boundaries for this exciting and you'll see somewhat terrifying use case. But to talk more about AI and the open source technology impact, please join me in welcoming Mark Collier.
All right. Thank you, Allison. Well, I was going to ask if any of you all have heard of this thing called AI, but apparently you definitely have now, if you haven't before. Well, I think there's 1.5 trillion reasons why people are talking about AI, which apparently is how big the market's going to be in a few years. And I want to talk about it today. First of all, in a few minutes, we're going to have a couple of amazing demos where we're going to show off some AI and open infrastructure in action. But first, I want to talk about AI from kind of two different points of view. One is to look at the impact open source is having on AI and how it's being developed, how that is changing the game in the AI world. And then I also want to talk about how AI is influencing, impacting how software is getting developed, particularly when it comes to open source. Now, when it comes to AI and giant companies that have been investing in it for years, one of them is Google. You've probably heard of them. And recently, there was a thorough analysis that was done within Google, and it sort of leaked out and apparently made it to the press. And so one of the big headlines was the author, who, you know, I think is not been revealed yet, but probably might be in a little bit of trouble. But I think they did a very honest analysis, and they said, we have no moat, and neither does OpenAI. And this is directly a result of open source. And I'll tell you a little bit more about the background. But if you don't know what a moat is, it's basically on an old castle. It's the water around there that's supposed to help your castle stop being invaded. In this case, we're thinking about competition and people trying to come in and get your customers and take away your competitive advantages. So this is a pretty big admission, albeit leaked out. But one of the big takeaways here was this quote which said, you know, while we've been squabbling, here the references to Google and OpenAI, a third faction has quietly been eating our lunch. I'm talking, of course, about open source. And so, you know, I personally think it's a lot of fun to drain moats with open source communities. So I'm all for this. And I think, you know, 1.5 trillion is a lot of lunch to eat. So I think we're all going to be eating well in the next few years if this trend continues. And to take a closer look at the data, one of the other pieces of analysis, and keep in mind, this has only happened in the last 3 months. You know, 3 months ago, we all believed that the only companies with access to this kind of powerful technology were 3 or 4 of the biggest companies in the world, the Googles of the world, the Metas, et cetera, OpenAI. And what has happened in just the past few weeks is through a lot of these open source models, as they said here, they, meaning the open source faction, are doing things with $100 and 13 billion parameters that we struggle to do with $10 million and 540 billion parameters. Now, there's a lot of debate about whether some of these new models are truly open source, depending on the license, but we're not going to spend time on that today. But the bottom line is open source is absolutely having a massive impact on AI, and the space is just moving really quickly. And the real summary here was we have no secret sauce, so, you know, I'm happy to toast to the end of secret sauce, but may not be gone forever. But certainly I think we are seeing signs that open source is having a massive impact directly on the development of AI. Now, talking about how open source rather is being influenced by AI, you know, I've been talking to a lot of developers, trying to get a feel for how people are using AI in the development of software and how they're feeling about it. And one of those developers who shall remain nameless said something that may sound eerily familiar. Oh, I meant to blur out his face. This is awkward. He wanted me to be sure to tell you he's a former software developer. But in any event, in a more serious note, we're already seeing how AI is changing how software is being written, how code is being produced. Definitely some developers are producing it, but I think the truth is we just do not know what the long-term impact is going to be on how software is produced. But we're already seeing some early signs of the impact and how it's affecting open source communities and other businesses. One example is in the Python community. They're starting to get more and more code submissions that need to be reviewed that are being generated by these sort of AI assistants, and it's creating quite a problem for the people trying to review the code. Quite frankly, some of the code is not very good, right? These AI systems are not magic. They don't actually always create great code, and oftentimes if the so-called contributor who submitted it is asked questions in the review process, they can't really answer them if they didn't write the code. So we're already seeing how this is creating problems, but it's also creating opportunities, right? And if you look at the publishing world, the world of sci-fi, we have this fascinating evolution in which sci-fi has been writing about AI for years. Now AI is writing about sci-fi. So it's kind of a funny turn of events. And I do have to say, though, this community, this sci-fi publisher community, I feel like they should have seen it coming, if anyone. But clearly all this change does create some opportunity, but it does create some fear. And, wherever there is fear, governments are sure to appear. And we are definitely seeing that happen. ChatGPT was banned in Italy and unbanned, and EU is thinking about passing various rules and regulations. But clearly, everybody is not really prepared, I think, for where this is all going. We, first of all, don't really know where it's going, but we're going to have to be on top of it. So some questions that we have to consider: what about the incentive alignment between organizations and open source moving forward? It's not going to be business as usual. What are we prepared for a world with code development without humans? In the future, more code will be written by machines than humans. So this is coming. In a lot of ways, it's here already. So are we prepared? Probably not, but this is the kind of community that can tackle these sorts of problems. How will the AI license us its code? There's a whole series of lawyers trying to figure this out right now. So I'm not a lawyer, so I'm not going to try to skip that one, but it's going to have to happen. How will we accept their code? And perhaps the biggest question of all, how will we accept AI as a member of our community? It looks pretty harmless, I would accept them. But, these are things we're going to have to think about. And we go back to the original premise of these two questions: how is open source impacting AI? How's AI impacting open source? The reality is these are inseparable at this point. You really can't separate the concepts at that point. They both are amplifying each other. Ideas are being submitted, combined, recombined, that are both AI generated and human generated. And let's face it, all those AI code generators were trained on open source code written by humans. But as we move forward, how can you really separate the two? They're sort of inseparable. The lines are blurring between human and machine. And we won't see a lot of code produced without some AI influence in the future. But the bottom line is we have a huge opportunity. That $1.5 trillion will probably keep everybody's attention, trying to figure out these hard problems. And right here in the OpenInfra community, we have lots of software that's already being used in production to power these massive AI systems. A lot of which you might not be aware of, but hopefully you will be in just a moment. And one great example of that is our next speaker, who does have a demo. And he is a longtime OpenStack Swift contributor. He was PTL for many years. Some of you may already know him from the past. He's spent the last several years at NVIDIA, and he's going to talk about how they're using OpenStack Swift at insanely massive scale to process all kinds of awesome data and machine learning. So John Dickinson, please come on up.
Thanks, Mark. Thanks, Mark. What I want to talk about is what does it take to actually do a lot of the machine learning? There's been huge advances super rapidly. It seems like every week there's something new. But when we peel back all of the new tools and abstractions and frameworks, we still see we have some familiar foundations. With all technology, we still have to deal with compute, networking, and infrastructure. And it's that storage infrastructure that I want to talk about. And how do we enable these kind of new tools? So on the compute and networking side, there's great advances. At NVIDIA, we've got things like the Grace chips and the Hopper chips and the Spectrum switches that are really pushing the edge of what's possible with machine learning. But let's talk about storage. Storage, how does that fit into the picture? AI and ML are taking off like a rocket ship, and the fuel that's powering that is data. So as storage providers, our job is to put as much data into that rocket engine as quickly as possible. And when you've got thousands of GPUs powering through petabytes of data, you need to be able to have high capacity and high availability and high aggregate throughput and concurrency. These are some of the baseline features that you need to enable you to put that fuel into the rocket ship as quickly as possible. But let's briefly talk about what these ML jobs look like, because it's really good to understand what the actual usage patterns are for this data access, but when you're going to build storage systems to support it. So in general, at a high level, a machine learning job will load some data, and then it will iterate on that, and it will shuffle the data every single time. So it cycles through the data over and over and over again in different orders. And each time it does that, it's called an epoch. So from a storage perspective, it would be great if you can reuse that data. And so you only have to load it into the GPU memory once, and then it can shuffle the data and retrain, and shuffle the data and retrain, and so on and so forth. So if you say, I've got 500 gigabytes of data that can fit inside of the memory on one server, and you can do that. You load the data in, you shuffle it, and you move it around and things like that. But the problem is, data sets are getting way bigger than that, and they can't fit in GPU memory. And in fact, they can't even fit on the flash storage that's inside of a particular server. So you think, great, well, let's use something like object storage, and that's really great. But a challenge there for machine learning practitioners is that it's a different API. Programming languages come with like F equals open, and they don't come with object level primitives. And for the repeated data access, you can think, I'll use caching, but that's going to add a lot of complexity to the whole how you put things together. And so you're stuck with this challenge that the people who are doing the machine learning are faced with these massive infrastructure problems of caching layers and file APIs versus object APIs and having to copy data between different systems. And that's not what they want to spend their time doing. And we're at an infrastructure conference. So our job is to build the infrastructure that enables them to do those things that were previously impossible. We have to build that infrastructure so that it gets out of the way and enables them to do their job. And so the users need these tools and abstractions to deal with the large amounts of data, to understand what kind of data they have, and to make it available to the GPUs as quickly as possible. So in addition to having really great compute platforms, you also have to have a really good storage platform. So to solve these problems, we use two abstractions. We have something called an inner ring and something called an outer ring. And the inner ring is high speed, it's low latency, it is tied to a specific GPU cluster. And normally, it's going to look like file storage to the end users. This is the storage acceleration layer. This is where caching would live. This is where the working set of data would live. And on the other hand, you've got the outer ring, which is very large capacity and high throughput, high availability, but not just HA in the sense that it's always turned on, but in the sense that it can be connected to many different GPU clusters at the same time. And this becomes the foundation for that whole data storage strategy. This is a very, very good fit for object storage. And Swift is one of the tools that we're using to internally implement our outer ring. So we first put the data into the outer ring. Then we can make it available to whatever GPU cluster we need and accelerate it as it's accessed through the inner ring pattern. And we get a lot of major wins from this. The first one, and the most obvious ones, is that we can support massive data sets that won't fit on single servers. We also are able to improve performance, because when you load that data into the GPU, you only have to load it from the outer ring once, and after that, you can accelerate it, and subsequent epochs can go to the inner ring storage. And you also get workload portability, because the outer ring, that foundation, is connected to many different GPU clusters. And so the job can run from many different locations. And so we use many different storage systems and storage providers and storage partners. And because we want to enable our users to use whatever they have available and the best tools that they have available. But the way we then have to do that is standardize around APIs. On the file side, it looks a lot like POSIX and NFS. And then on the object side, it's going to look like S3 APIs and Azure Blob and the Swift API. So Swift is something that we use internally. It's a great storage system for the outer ring. It has high throughput, high capacity, and we've got several large deployments there. Right now, we've got about an exabyte of Swift deployed, supporting many different GPUs clusters. But giving people that inner ring and outer ring is really great, but it's not quite sufficient. Because the problem is then, what data do I actually have? And when you get bigger and bigger data sets, it gets harder and harder to understand what these data sets actually look like. How can I explore petabyte scale data sets on my laptop? So we've created also a dataset service. And its end goal is to give users a way to explore things without having to worry about that underlying storage. This is what I'm going to demo, kind of the end user view of putting these storage systems together in a way that makes the large scale ML possible. So first, I'm going to load a data set into Swift. Then I'm going to explore it in a Jupyter notebook without having to worry about the storage, and then finally run a small ML task on it. So first, I took an extract of some of our internal Confluence pages and extracted that as JSON. And we can see here that it's a bunch of different files. The first one starts with 026, and it's about 30 kilobytes, and it's got an MD5 sum that starts with F3 E6. We'll come back to that. And the structure of these JSON files is pretty simple. But one of the key things, again, we'll come back to in a second, is this source URL, that every file has that. So when I create the data set, what this is going to do is upload this data into Swift. And then I also noticed I told it about the source URL key there. It's going to upload that data into Swift. It's going to create it inside of a new container there. And then from that point, we can go explore that container inside of Swift using standard Swift APIs and see exactly what data is there. Now, the point of that is the data is exactly the same as we started with. The names are exactly the same. The first one that I'm going to pull up here starts with 026. You're going to see that it's basically 30 kilobytes, and the MD5 sum is exactly the same as the one that we had locally. The really cool thing about this is that there's nothing standing in the way of the actual data access. There's nothing translating or transferring that. You don't have to go through other systems. You can still directly use the object storage. So here you can see that object, that 026 object, is still exactly the same one that we started with locally. So once I have this data set created, then I've started up on my laptop a little Jupyter notebook to say, let's explore this data set and see what it looks like without having to load or even worry about all of the data storage. So when I start the Jupyter notebook, the first thing I do is I pull up a list of some of the data sets that I have. You can see there's several of them there as I was building this over and over again, preparing for this. And then I specifically load the one I'm interested in here, the one I loaded, John Vancouver demo. In that, you can look at the metadata. You can see that it's 40 files in total, and it's a few megabytes in size. And then the really cool part here is that you can convert it immediately to a pandas data frame, which is the exact tools that people are used to using. And when I do that, note that it has the source URL there exposed, which means that I can now start playing with a little bit more about what I knew that was in that data and start doing different things on it. Other examples is let's chart out the sizes of this data set and see what it looks like. And you can see most of them are small and one of them is kind of big. But what's really cool about this is in no point whatsoever when I've been exploring this, have I ever hit Swift. This is the log indexes here, and you can see there's no requests that go to Swift. So if I wanted to actually load one of those data objects in there, I can do that without having to know anything about how it was actually stored. And here where I load it out and show out the first 100 bytes, you can see that that's the content. And once I have that content loaded, I could put it through a simple lang chain summarization tool and figure out that, oh, this particular file, this extract from this Confluence page was about how to handle some communications during an incident. So in review, what I was able to do here is load the data directly into Swift, explore the metadata without having to have that data loaded locally at all, and then load some of the data from the data set without having to worry about what the underlying storage was, and then integrate that into existing tools, things that are available elsewhere. So by putting together these storage and data platforms, we're able to, there was the one, sorry about that. There was the one actual request that went back to the log index system, and you could see that it was actually that single request to hit the back to the Swift cluster. So by putting together these storage systems, we're able to solve these problems for ML practitioners at scale without having to worry about those underlying storage systems. This is what helps us to continually feed that machine learning rocket. And Swift specifically has been a key part of one of our internal systems to help grow our storage platforms. Thank you.
All right. Before you go, I'm going to hit you with one more question.
Sure, Mark.
So, well, I was backstage. I think I heard you say NVIDIA is running an exabyte of OpenStack Swift for your AI system. So that's incredible. I imagine you must have been making some improvements to Swift over the years to get ready for this type of crazy workload and scale.
It has grown very quickly, and that it's been critical for us to be able to have access to the code, participate in the community, push the changes back up, because anything at that scale has to grow super rapidly, and we continually find new ways to improve performance and improve the scaling ability.
That's amazing. Well, thank you so much for the presentation and talking about your Swift at NVIDIA AI use case. So next up, we have another awesome user who's running OpenStack at crazy scale for AI, and we're going to have Nathan Harper from GraphCore and John Garbett from Stack HPC. So come on up.
Hi, I'm Nathan Harper from Stack HPC. From GraphCore, sorry. There's too much Stack HPC going on. So I'm really pleased to be here to be able to talk to you about how we have been accelerating development using OpenStack and infrastructure as code. So very quickly, who are GraphCore? So we develop hardware, software, and services that have been designed from the ground up for AI and machine learning. So the focus for us for this particular project has been our IPU machine. So this is the system that's down the bottom right-hand side. So although this has got a server form factor, it's actually, this is a network accelerator, or a network appliance. So this has got 4 of our IPU processors in it, and then it's accessed over the network from an application server using our IPU over Fabric protocol, which leverages RDMA. So the challenge that we run into is we were building our systems that look like this, effectively by hand. So each one of those racks contains one of our reference Pod 64s, and although we've got automation and config management for managing the actual servers, managing the infrastructure, so the IPU machines, managing the network infrastructure, that is all very static. If we had any requirements for any alternative configurations, for virtualization for Kubernetes, all of that had to be managed by hand and managed centrally. So we were really challenged to how do we improve our developer enablement? How do we make sure that our developers have got access to the infrastructure and the systems that they need when they need it? And the byproduct for that is also to improve our utilization. So to ensure that we don't have systems that are sat waiting for reconfiguration to be upgraded, for the config to be changed so that they can then be used. So we decided to build a Loki-based IPU cloud. So this is built primarily on OpenStack. And we developed the concept of our vPod, or a virtual pod. So a vPod includes our IPU machines, includes the application servers that users will be using to actually drive those IPUs, and the networks associated with them. And so we had 3 principal requirements when we developed these. So that was around having kind of isolation, trying to prevent noisy neighbor, trying to prevent users from accidentally trampling all over each other. They also had to be performant, so we didn't want to sacrifice any of the performance that we get by automating this way. And ideally, we also wanted to make this self-service so that users could drive their own destiny rather than having to rely upon central services. So rather than going and doing this alone, we enlisted the support of Stack HPC, who've got a wealth of experience with running high-performance workloads inside OpenStack. So I'm going to hand you over to John, who's going to be able to tell you a little more.
Thanks, Nathan. Yeah, I'm John Garbett from Stack HPC, and I'm going to dig into some of the bits and pieces we've been working on, so the fruits of this collaboration between Stack HPC and GraphCore. So I'm going to start with looking at the isolated vPods. So we're using Ironic, and with that we're using Neutron, and in particular its networking generic switch driver. And what that lets us do is it lets us reach out to a physical switch and change the access VLAN. So if you go back to that rack of IPU machines that Nathan was introducing, there's 16 IPU machines in there, and that allows us to move from 16 isolated IPU machines, all in their own VLAN, to a rack that's joined to multiple racks all together into one unit. And we get to move between that as the use cases require that. So that's one side of it on the IPU machines. So to talk to the IPU machines, we need some x86 machines running the Poplar SDK. So to start with, there's 4 x86 machines in each of these racks. And we can use those as bare metal machines within Ironic, and that's great. But very often we need to slice it up a bit thinner than that. So we could, for example, have 16 VMs using Nova and KVM and slicing that up. And each of those VMs can be on a separate VLAN talking to the IP machines. So you've got that ability to have one multi-rack system or lots of these small development environments. So that's kind of the isolated vPods, the slicing and dicing. So these need to perform to work well. In particular, the Poplar SDK, in order to talk to those IPU machines across the network, we need to have RDMA connectivity on the network. And we do that using SRRV, so passing the network card into the VM. So we don't just use any old SRRV, we're using VFlag, using an OVS offload SRV. And what that really gives us is it's for a machine that's got 100 gig Ethernet bonded, we can get that full performance inside the VM. And that's both for the RDMA connectivity and for TCP connectivity, reaching out to NFS storage and such like. So we've got the network sorted, we've got those things connected together, and we've got that using Loki to get that sort of dynamic infrastructure. So we need to really test the performance, and for that, we're using MLPerf. So with MLPerf, the basic idea was we test and make sure that in all of this virtual world, are we getting the same performance we got on bare metal? And we're able to do that and make that repeatable with a whole bunch of things. We'll go into more detail in our breakout session later. So all of this is for naught if the users can't actually use it when they need to. So for this, we're bringing the open source project called Azimuth. This was started in Jasmine, which is a UK institution for environmental science. And at Stack HPC, we've been working at lots of different scientific institutions within the UK to sort of apply Azimuth to different situations. So for example, IRC infrastructure, Dirac supercomputers, recently with the SKA UK Regional Centre, and a lot of that work's been in concert with Cambridge University. And so with that, we've built up a set of reference platforms. We're actually using Cluster API to drive Kubernetes on OpenStack. We've got full stack Loki apps in there. And this isn't just a sort of static set of apps. This is extensible. And GraphCore have been able to take this and actually package up the environments that they need to offer. So I'm going to hand back to Nathan, who's going to go through bits and pieces of what GraphCore have been doing with this stack.
So the advantage of making use of Azimuth is that because it's using Ansible and Terraform on the back end, that means that we can quite happily inject any of our own configuration, any of our own orchestration that we need to into that. So as a cloud provider, being able to develop applications and appliances with all the sensible defaults baked into them, it means that users don't need to know the ins and outs of the infrastructure. They don't need to know how to turn on SRIV or to ensure they've ended up with the right flavors to achieve their full fat performance. So this runs, we have your pre-built images built by Packer. This means that all the applications and configuration is pre-baked in, and then Ansible then applies the Terraform to apply that to the cloud. And then once it's been stood up, then users can access either via SSH or via a web console that is accessible through the Zenith proxy built into Azimuth. So demo time. I'm hoping the other presenters haven't used up all of the kind of demo luck. So I can just very briefly show you some of the user experience. So this is the Azimuth front end, and these are some of our popular appliances that I've pre-built. And so the kinds of options that users can access, they can choose their name, what operating system they're going to use, in this case, what style of IPU machine, how many they want. What you'll see is actually some of these options are mutable. So once a user has deployed a system, they can actually choose to resize it again at a later date once they've worked out what they might start small and then choose to increase to later. And one of the things we've used to drive our utilization is by setting maximum lifetimes so that things don't just end up languishing. So in the background, this is actually running, because we're running Ansible, we can use Ara to grab all of the output. This is quite useful for debugging. And as you can see, this is just running through some Terraform. So the advantage of making use of our Terraform modules is that we don't need any other fixed infrastructure to run this. So we've got a small vPod here, which has got a couple of application servers and some of our IPU machines. And so what I'm going to do is I'm going to add an extra couple of IPU machines into this. And then go ahead and run the Terraform. So I'm just adding another pair of IPU machines. So these IPU machines are enrolled via Ironic. We're skipping over the vast majority of the functionality. We don't need to worry about pixie booting and provisioning it. But the main thing really is that we want it to manage the network interfaces and move them into the correct VLAN. So when I'm running this, this is going to be, Ironic is calling out to Neutron and NGS, which is going to update the VLANs, the access ports that these IPU machines are connected to. And so this means that we can just really treat these IPU machines as first-class OpenStack citizens. And once this is done, I've hopefully got a, oh, there we go. As we can see, the ping that I had to an IPU machine has now started running, which means that all of our networking has been connected back up again. What's next? And so if you're interested in IPUs and you're making use of the IPUs because you want to run your own AI, you can try out IPUs for free in Paperspace, which is you can access via the first link. If you want to try out Azimuth in your own OpenStack cloud, then you can also take a look there. And if you're interested in knowing a little bit more or finding out about some of the more in-depth bits and pieces that we ran through when we did this, we've got our breakout session later on this week. So thank you very much.
All right. So, quick question. You mentioned Paperspace and some of these other environments you've got running OpenStack, but how many OpenStack clouds have you got? What else are you using it for in AI?
So we're up to about 5 OpenStack clouds now, and you're running on, I don't know, 20, 25,000 cores at this point. One of the things that's been a real enabler is that as well as running our self-service systems that I've been able to show you today, we also have Slurm-based HPC systems, we have CI-driven workloads. All of this is able to run inside a single control plane, a single OpenStack system. And it's a pool, so we can move resources between those workloads depending upon what is needed.
All right. Well, thank you all very much. That was a great presentation.
Thank you.
All right. Well, as I mentioned, they do have a session that you want to definitely attend and learn more. And as we wrap up this AI segment, just another reminder, there's tons of conversations going on all week. This is the place to talk about open source infrastructure, AI, and the intersection there. Here's a few other sessions that you want to check out. And that's it for our AI segment. Thank you very much.
All right, thank you. Yeah, that was very interesting. It is super interesting to see how open source is impacting AI and obviously causing that massive growth. But anytime you have that kind of growth, security obviously becomes an issue. So coincidentally, that's what our next segment's about. Let me bring on the Executive Director for the OpenInfra Foundation, Jonathan Bryce.
Thank you, Wes. And I just wanted to actually take a minute to recognize Wes and Allison, who were promoted to VPs in the OpenInfra Foundation earlier this year. So congratulations, Wes and Allison. Our lovely hosts for the day. So Wes mentioned that we're going to talk a little bit about security now. And when I talk about security, I always talk about how security is a very, very layered and complex topic, because there's nothing static about security in the technology world. There are always new techniques and new technologies that we need to be implementing. And if we think about the infrastructure landscape, we started with servers and VMs in kind of data centers, early clouds, and a lot of times at that point, security focused on perimeter security and network security. What we have now is a world where we've introduced containerized applications where you may have code running in thousands, tens of thousands, hundreds of thousands of containers that may be moving between servers. As we look at things like public cloud container services, we start to see multi-tenancy. And this creates a much more complicated security scenario where you have to now introduce new techniques and new technologies. And within the OpenInfra community, we've been building technology to help give operators new tools to manage this kind of a security environment. A big one of those being Kata containers. Kata containers provides strong isolation, but in a very lightweight way, so that you still get all of the benefits of speed and density from containers, but you have a stronger isolation mechanism around them that gives you better security. It also enables certain features that you might want if you're trying to pass through hardware up to an application. What we've also seen, though, is that with the original versions of Kata containers, we're not just wanting to isolate containers and workloads from other containers and workloads. But as we move into more and more adoption of this, as we move into a world where we see things like the AI workloads that John was talking about, we have assets in our containers. We have assets on our servers that in some cases are some of the most valuable IP that businesses own. These models, all of the data that is contained with them are extremely valuable for these businesses. And they want to make sure that that data is private, is secure, and remains secret to them. And there's been a new movement that's been emerging over the past few years called confidential computing. And here we're not thinking about just workloads and tenants from each other, but we're including in our threat model and in our security model, how do we make sure that even if someone has physical access to a server, that my workload, my data, is still secure and secret from them. And so we see hardware support with things like AMD SEV. We see various types of networking stacks and container stacks that wrap this up. And we have seen this support coming into Kata containers with the Confidential Containers project. Kata was started a little over 5 years ago. And to talk some about these container security implications and the progress that we've made as a community, I want to invite up two of the first engineers of the Kata project who are going to do a demo and talk about this. Help me welcome Wang Xu and Peng Tao. All right, Xu.
Thank you.
Tao, welcome. All right, go get that set up. Let's make sure we've got the, we're going to do more live demos.
Yep. Thank you, Jonathan. And thank you all. And I can still remember the 5 years ago, 2018, in Vancouver. And at this stage, I, together with Amy, to announce the 1.0 release of Kata containers. And today, this year, we have released the 3.0 version. Yeah, I'm Wang Xu from the Ant group, and also I'm the co-founder of the Kata containers project. And this is my team member Peng Tao, and he also writes the first line of the Kata code. Yeah. So introduce yourself.
Hi everyone, it's a pleasure to be here demonstrate to the demo.
Yep. And for the Kata, the 3.0 release, we introduced the Rust implementation of the runtime part. Yeah, and also we have a built-in hypervisor, built-in VMM for the sandbox, so you can run one pod in only one process, and this is which improve in the architecture, and also we have introduced the confidential container support. It's about the confidential computing. When we introduced Kata, it protects the infrastructure itself from the workload. If there is something try to attack in the inside the sandbox and get the privilege, it cannot escape the sandbox. And in some critical workload, such as the financial and some other privacy, you need to protect your content from the infrastructure. I mean, if there is anything wrong in the infrastructure, they cannot access the content of the inside the sandbox. So that's the confidential computing, and we have introduced an initial support for the confidential container called Coco. That's confidential container. Yeah. And today we will do a demo for it. And
all right, are we ready to go?
Yeah.
Got this demo. Okay, great.
Yeah. Yes, we will show a live demo. So this is run on the Alibaba Cloud. It's a commodity server with the ICV support. Yeah. And we have heard a lot of AI things in the keynote, and this one is also AI related. And we have introduced Llama, the large model inside the container. Yeah.
So you're going to be running your own large language model inside of a container on a server that supports SEV for the memory encryption.
Yes, but right now I think we still should wait for it.
Okay.
Yeah. At the first day we launched the Kata. Okay. Yeah, we said the slogan, the secure of VM and the fast of container. Mm-hmm. By today, it's launched in 35 seconds. Not really slow, right? Yeah, because it's confidential, so it's a bit slower. Yeah. And because it's a confidential container, so if we try to use the exec to access the content of the container, you can't. We have stopped this way, and also you cannot access the memory of the container from outside. but you can still use SSH to log in it. Yeah. Show NAS. Yeah. And show the CPU features. Yeah. Yeah. You can find the ICV inside. So we have already run in the confidential part. And yeah, let's try to chat with it. Okay?
Yeah, up and running.
Okay. What's the question we should ask it? And let's explain the theory of relativity. Okay.
Okay. Okay.
Oh. It's created by Einstein. Yeah.
It's a good explanation of it there.
So long. Can you ask it stop?
Okay, you finish it.
It stops. So after it stopped the relativity, and yeah, we have another question for it. Yeah, we have asked it to, I think earlier minutes ago, Mark has said some.
This is Mark. Yeah, we're writing the code that Mark was talking about.
Yes. Write a program without a programmer. Yeah.
Okay.
Yeah. We have become a prompt engineer. Yeah. Well, in Go. Yeah. Cool. Yesterday in rehearsal we used Python, right?
It knows many languages.
Yeah. We just ask you to write the program, and we cannot guarantee it can run. Okay, enough. Okay.
Who knew AI was so talkative?
Yes. So you're more than me. So this time we bring several kata-related topics here, and two of them about the kata architecture. So let the AI tell us which one is better. The first one is about the architecture of Kata 3.0. That's from the Pengtao itself. And the second one is about some new feature we will introduce in Kata 4. And it is...
wait a minute.
Okay.
Which one?
Were you training this model?
No.
You bet it.
Because every time we create a new container, so the last one is destroyed. It has no chance to learn from what we try. Yeah. So, probably go with the topic Pengtao. Oh, what a pity! You cannot try this topic. This topic have already finished. It's 12 p.m. today.
Okay.
Yeah. So that's all. That's our demonstration. You can say goodbye to it.
Okay.
Yeah.
That's great.
Yeah. See you. Yeah. Oh, that's all the demonstration of Kata. And I think for the AI part, the confidential about the GPU in Kata is not really ready right now. But we just run it in the CPU, so it's a bit slower.
Yeah.
So yeah, that's all the demonstration.
Yeah. Well, thank you for demonstrating that. It's awesome to see, like I said, the way that. Yes. that the community is building new open source solutions to take care of the new architectures. And yes.
This way.
Bye. There is another session tomorrow, as well as Thursday, where you can go learn more about the next Kata containers developments. So moving from the engineers who are writing the software and kind of helping us see where we need to go with container security, I want to actually move now to hearing from some operators who are running this. And these are operators from Microsoft who are implementing container security solutions in the Microsoft Azure Kubernetes service. So this is really cool to have Microsoft Azure represented here and coming to talk about what they're doing, and also to have them participating in the OpenInfra community. So please help me welcome from Microsoft, Amr and Michael.
Thank you very much. Thank you. All right, here we go. Hey, everybody. Glad to be here. My name is Michael Withrow. I'm a product manager on the Azure Kubernetes service.
My name is Amar Gowda. I'm Principal Product Manager in Azure Confidential Computing. I've been part of the team for the last 5 years.
Amar and I essentially are working together to bring all the confidential computing capabilities that exist out in the ecosystem into Azure Kubernetes service. So today, we're going to kind of talk to you through a couple of different options, essentially walking through Kata confidential containers to achieve zero trust operator deployments within Azure Kubernetes service. All right. To start out, at Microsoft Azure, we love open source. What does that mean? Not only do we consume open source, but we actually heavily contribute to open source. So there are many initiatives across the open source community that we are heavily, have a lot of developers in that heavily contribute to make the open source capabilities work natively within Microsoft Azure. Obviously, open source remains a big differentiator for organizations. There's many different communities, capabilities that exist. From our perspective, the big thing that I want to call out that's important to understand is because we have all the developers integrated into the upstream communities, we actually natively leverage the APIs that come from the open source community. We don't proxy, we don't fork any of those things off, so that everybody gets the benefit of everything that we're building as well as we do. So with that, essentially, as we talked about, this is to announce Kata containers for pod sandboxing on AKS. Essentially, we've technically had this in public preview since February of 2023. We're working heavily towards GAing this feature set. When you look at the scenarios, obviously the big theme that we're hearing from a AKS perspective, Kubernetes perspective, a lot of talks about this, is how do I leverage multi-tenancy? How do I bring multi-tenancy to my environment? Typically, a lot of customers deploy a single cluster, deploy one application in there, and they're looking to make that deployment a lot more dense, a la multi-tenancy. So when we look at that, obviously from an AKS perspective, not only do we have a lot of S500 customers across the globe that are running on top of AKS, but a lot of Azure services also run on top of AKS as well. And the theme of what they're looking for comes from both of those initiatives. So when we look at the implementation from a Kata perspective, obviously starts with the Microsoft hypervisor, nested VM capabilities, and then we actually integrated Kata with our cloud hypervisor capability as our virtual machine manager. Now I'll kind of turn over to Amar to kind of talk about confidential containers.
Thanks, Michael. So we did not stop here, right? So Kata gave us an amazing platform for VM-level isolation. And we have offering, and Azure has been a pioneer and one of the co-founders of Confidential Computing Consortium back in 3 or 4 years back. So we have invested heavily into confidential computing, and we want to build on top of it. You saw a demo from Ali just before about confidential VMs and what AMD, SCV, SNP has to provide. So we've been actively contributing and working with confidential containers, which is part of the CNCF incubation, going into sandboxing very soon. Right? So we want to work with the community, build with the community, and have an offering where you are empowered to run the same stack wherever you want to run. Right? So that's the strongest fundamentals we're building on top of. So some of the contributors to Kata confidential containers are Intel, AMD, NVIDIA, hardware providers. You have Red Hat heavily invested into this. One of the co-founders for Kata confidential containers, or COCO is how we call it. So what's this looking like on AKS? So we just last month announced upcoming preview, right? This is a ready going public preview, where you can run confidential containers on AKS, first class, fully supported, with AMD SEV SNP, which is the next version of SEV with higher confidentiality and code integrity promises. I have a slide that talks about how we extend the confidential inferencing, model protection, as well as attested inferencing, where your data is private, but you are checking if this is really genuine confidential computing environment. We've been in this for pretty long, and we have journey and look at the comprehensive set of services that we have announced. That includes the data stack, just not the infra stack, but we have the whole of the container stack, as well as the services on built-off. So this is a whole ecosystem of offerings we've fully invested into how you can achieve your end-to-end confidentiality goals. It's just not about processing the data in a TEE. You can go to store that PII data in a private data somewhere, right? So this is going to allow you to achieve your full end-to-end goals. We also have developer tools on top of this as well. So let's look at what Kata Coco has to offer and how and what tech stack we are building this on top of. So first to start with, right? So it's a big Kata containers is a baseline. Kata confidential containers is the next layer. We run confidential VMs as a micro virtual machines that are very ultra lightweight, highly hardened, and full attestation capabilities that run AMD, and we're going to invest into newer hardware as they become available. One thing you saw previously is we have Intel TDX offerings as well going in private preview. We also have NVIDIA GPU going into H100 confidential GPUs as well. So we are one of the first vendors to announce support for NVIDIA as well. Some of the scenarios, the confidential computing is cool, but can I use it for everything else? Yes. If you really serious about confidential security and securing your code, and you have low trust on the provider, this is a way for you to get into this. You can go to that MS link to read more about Coco and AKS. So the tech stack is built on the same cloud hypervisor as a virtual machine manager. We run nested VMs. This is our start. We're obviously working in other technologies to expand into non-nested as well. This is running Microsoft hypervisor with cloud hypervisor to orchestrate all of this. So you're going to just run a single AKS worker node, but AKS worker node can get partitioned into tiny VMs, and each VM is a confidential VM. That's how our architecture is. We have a dedicated session tomorrow. We go into this. We show you a demo as well. I'll quickly go to that slide. So what are the goals? So we have Coco. Here are our protection goals. We will protect you, and we plan to, and our North Star goal is to protect from all of these parties, right? So you are control of your destination and the code you trust and run. And every code that is part of your TEE is fully open source and auditable. This is a big differentiator for us compared to other providers. All right, so quickly going into how this would look, for example, in the world of AI, right? Very relevant. Model protection, you saw our demo. We're extending it even further. You could do attested TLS. Even before you saw your responses, you're asking questions to large language models. You can challenge the model as like, prove you are running in a confidential environment and meet my security baseline. That's when your client and browser is trying to do that authentication. We call this mutually attested TLSs. And that's when you start doing inferencing. So your data is fully private from the cloud provider, and the only thing that is accessible to you is the code and the session that you have with the client. This is how we are enabling. You could learn more in the upcoming session. So please stop by. We have a demo. We have a streaming analytics using Kafka running Dapper. I'm going to show you a demo of how we're going to do that with Coco on AKS. Thank you all. This was amazing. Thank you.
All right, thank you. That was a very quick overview of a lot of information. So make sure you get to their session where they're going to have time to dive deeper into it, and they are also doing a demo at that, and that's going to be tomorrow morning. So we've talked a little bit about some of the projects that help us secure our workloads. One of the things that we need to be thinking about is also how do we secure our projects? What should we be thinking about as open source communities and developers, especially in the context of what Thierry talked about earlier this morning, where we really see governments around the world waking up to the ubiquity and power that open source software communities kind of wield and create through their work. And so we're going to take a little bit of a moment here to hear Some of the things that we can think about as architects, developers, community leaders working in open source to help make sure that we are thinking strategically and putting our projects on a good track. So to talk about that, help me welcome Ava Black.
Hello, folks. Good afternoon. I know we're getting towards the end of the day, so I'll kick us off here by saying sometimes it's hard to think about things in the abstract. We've probably all been hearing a lot about SBOMs and supply chain security, but I'm going to take this back to something tangible and, well, one of my favorite things, pie. And I won't stand in your way between going and getting some pie after this for too long. This is a pie that a friend of mine baked, a lovely smoked apple pie, but if it was sitting here in front of you on a table or on the stage, would you just walk up and eat some without knowing anything else about it? Probably not. If it had a list of ingredients next to it, you know a little bit more. But is that enough? Do you know, were the ingredients expired? Were they subject to a recall because of some contamination? Was the flour gluten-free? It doesn't say. Is the cookie even any good? How would you know? Is the list even accurate? And ultimately, if you got sick from eating the pie, do you have any legal remedy? The answers to all these questions are supply chain questions. And this is where food safety and a lot of other regulated industries have rules that they have to follow. Cybersecurity, not so much. How does open source fit into all of this? Well, as Thierry was saying, open source is everywhere. It's in everything. It's all around us. Black Duck is a cybersecurity company. They publish a pretty good report on the security of open source projects. I think this was their 8th year doing it. And in it, they point out that 96% of all software stacks that they surveyed contained open source. 91% of all stacks contained open source that hadn't been patched in more than 2 years. And 76% of all code that they surveyed in those stacks was in fact open source. So really, it is in everything all around us, from our smart light bulbs to airplanes and F-16s to gas pipelines and pacemakers and banks. The analogy here is that corporations have been selling pies without necessarily doing good quality control on the ingredients or telling, claiming it's not their fault if people get sick because Log4j wasn't really theirs. It was just an ingredient they sourced. And I've said for a while that open source has suffered from profit-motivated insecurity, and I'll explain what I mean by this. You've seen a couple timelines today. I go back to about 2010, roughly, when I saw the growth of this begin with financial incentives to hold back operability, observability, maintainability, and ultimately security from the open source commons, which isn't a big deal if you're buying the product from the vendor. But remember, 75% of all code in all the things all around us is open source. So if it's being deprived of security, that actually does affect all of us. And governments have noticed. Right? So the White House and the Office of the National Cyber Director put out a statement and a new strategy for the US's cybersecurity plan a few months ago that even calls out this practice directly. Now, no company would sell a pie in a supermarket without a list of ingredients, but effectively the software industry has been selling pies to the government and to consumers without transparency, and that lack of transparency prevents consumers from acting in their own interest. Now, the White House in their strategy also calls out open source and that they're trying to hold responsible those stakeholders who can solve this without burdening open source developers. Great innovation engine we all have built here in the past 15, 25 years. Let's keep it going. But European Union may be taking a different approach. I know the OpenInfra Foundation put out commented on this, as did many other foundations, as the OSI helped with some of these. I think the Eclipse Foundation's write-up has been one of the most thorough. It's unclear how this will play out in the next couple of years. Regardless, it is clear that SBOMs are here to stay. They are now part of US federal procurement requirements, and the minimum bar is pretty low right now, but that bar is being raised. There are already new regulations in addition to SBOM under review in the US. And ingredient lists are not the end of the supply chain story for food. or other regulated industries, I predict they won't be the end of it for software either. We will need to have the equivalent of food safety ratings, expiration dates, the little traceability barcode on the bottom of a can of soup that enables a recall, a federally coordinated rapid response to vulnerabilities. All of the tools for that are being investigated or invested in and built, many in open source. And that is the role I think foundations can play best, to raise the bar for all the projects hosted in a foundation, to build security into the development lifecycle of the projects and thus the products that depend on them, to coordinate with corporate sponsors while prioritizing the needs of the individual maintainers, without whom none of this goes, and to partner with other foundations to work with each other and collectively advocate to governments for the right balance of regulations and to build the right tools that benefit all of us. I don't have enough time to talk about all the awesome tools out there. This is a super, super short list of a few of my favorites, and I'm going to highlight 3 of them for you. I think one of them even has a talk here. This is a little last minute for me, so I'm not sure which ones. 2 standards coming out of the OpenSSF that describe this space. SALSA is a standard to assess safe development practices in open source. Now, it's heavily inspired by practices that were pioneered and encoded in the OpenInfra and OpenStack Foundation's Infra team a decade ago. The goal here is to normalize those across all of open source. And the secure supply chain consumption framework is the counterside to that. How do you consume it safely? The Omniware project I helped start last year, the goal is to, without needing any project-level changes, help embed traceability throughout the entire supply chain in a binary way. Again, the goal being 0 effort for developers on this one. And then lastly, a little project that might have spun out after a bunch of conversations we had to help assess the risk of a project, not just based on static analyzers or dependency checkers, but on the community's development practices. And this is kind of also similar to a scorecard project in the OpenSSF, which HipCheck takes as one of many inputs. So thanks so much. Please get involved. Raise the bar of security for all of us. Thank you.
Thank you, Ava. As I said, security has many facets that we need to think about when we are wanting to build it into our environments and our projects and our software. And so definitely thinking about these types of policy issues and the processes that we undertake in our projects is going to be more important going forward. We have a number of sessions that you can check out over the next couple of days related to security this week. And if this is a topic that you want to spend more time on and contribute to in the community, please join these sessions. So that wraps it up for this segment. And I am going to hand it over for some exciting Super User Award announcements now.
Yeah. All right, so there's 2 things that I love in this world. One is data, and one is organizations who talk about how they're using open source infrastructure in production. So the Super User Awards have been around since 2014 to recognize organizations who not only operate open infrastructure, but also have contributors back in the upstream community. So to crown the winner for the 2023 Super User Awards, please help me welcome Shu Wang.
I'm back.
You're back. Sorry, we had to pull him away from the demo. Yeah. So yes, last year in Berlin, Ant Group was one of the winners of the Super User Awards. Yeah. So we're excited to celebrate in person because y'all weren't able to attend last year.
Yeah.
So welcome. But yeah, so first we're going to acknowledge all of the nominees because we had so many great organizations nominated, and not just for one project. Most of them talk about how they're leveraging and contributing to multiple open source technology communities. So the first one is an organization that supports Zool installations that run several thousands of jobs per hour, which is?
Yeah. It's Acme Gating.
All right, the next one is an organization whose global compute and storage investment consists of over 400,000 OpenStack cores, several petabytes of RAM, and hundreds of petabytes of replicated Ceph, block, and object storage.
Bloomberg Engineering.
The next nominee has contributed over 40,000 lines of code to the OpenStack project, which is significant, and other communities like Linux. They have also contributed over 30 commits and 1,000 lines of code to features such as dirty limit and issue fixes.
Oh, it's China Telecom and Tianyun.
The next nominee has multiple systems running Starling X in test environments on behalf of their customers in the last 3 years and have been actively involved in the Starling X community. And they're also our first nominee for the Starling X project.
Ancora.
So our next nominee is a cultural and tourism industry provider in China that has formed by integrating different public clouds and private clouds for various business sectors in a certain province.
Hubei Joint Technology.
Our next nominee offers documentation and tutorials on our wiki and blog for a wide range of open source technologies. You can actually find a lot of those directly on SuperUser itself, which makes them a great nominee.
Keepsake Technologies.
Yeah. And the next nominee, their storage and computing capacity is distributed among multiple OpenStack private clouds and supported by other open source technologies like RabbitMQ and MySQL.
OpenMetal.
Our next nominee, we have a lot this year. Like I said, there's a lot of organizations innovating with open infrastructure. So Workday has talked a lot in the OpenInfra and OpenStack summits before about their OpenStack usage. What's really exciting is they're here this week to talk about their Zool usage and how they migrated from Jenkins. But they also leverage other open source projects like Ansible and Calico and have over 3 million cores of OpenStack in production.
Workday, and this is not the last.
Oh, sorry. All right, last one, I promise. So this is another Zool user. So they have, with its modern tool chain of Zool, Ansible, and Calico, as well as some custom tooling, they, this is the wrong description, but I still want to recognize them. So TPG Telecom is actually an OpenStack user, so we'll still recognize their contribution to the community.
Yep.
All right, so this is the moment to decide who we're going to give it to. Ready?
It's Bloomberg Engineering.
Congratulations. Thank you. I think we have a special trophy.
Congratulations.
I don't know. Are there any other Bloomberg folks out there? All right, come on. Come on stage, yeah. Congratulations.
Congratulations.
Congratulations. Oh, there's more. I thought so. All right, well, join me in welcoming Bloomberg to the Honorary Club of Super User Award winners. All right, so I know it's been a very long first day, so all we want from now is to have a great time with OpenInfra. Are there more coming?
There you go. Come on out.
Oh, okay, so Thierry did say that anything became everything that open infrastructure is powering, and we do have an OpenStack powered baby now, so congratulations to Jonathan Bryce for his new addition to his family. It's his first keynote, yes. All right, thanks, y'all.